Hello everyone and welcome to the Backend Masterclass. In this lecture, we will learn how to use another service, AWS Secret Managers, to manage the environment variables and secrets for our application. If you remember, in the previous lecture, we have set up a production database on AWS RDS, and this is the URL we use to access it. When we deploy the SimpleBank app to production, we would want it to connect to this database. So basically, we must replace the DB source variable in the app.env file with the real production DB URL. Also, we need to generate a stronger token symmetric key. We should not use this trivial and easy to guess value, right? So the idea is, in the GitHub Actions deploy workflow, before building and publishing the Docker image to ECR, we will replace all environment variables in the development app.env file with the real production values. By doing so, when we run the Docker container on the server later, it will have all the correct settings for production environment. Okay, but the question is, where do we store the values of these environment variables? Of course, we cannot put them directly in our GitHub repository because it will be very insecure, right? One good solution is to use AWS Secret Manager service. This service allows us to store and retrieve any kind of secret for our application. It's pretty cheap. Just $0.4 per secret per month, and only $0.05 per 10,000 API calls. And we also have 30-day free trial period. As we have planned to use AWS to deploy our app, it totally makes sense to take advantages of this secret manager service. Okay, let's create a new secret. There are several types of secret, such as credentials for RDS, DocumentDB, Redshift, or other databases. In our case, we want to store not only the DB credentials, but other environment variables as well. So I'm going to choose other type of secret. In the next section, we can add as many key value pairs as we want. First, let's add the DB source. I'm going to copy the production RDS database URL from the make file and paste it to this input text box. Then let's click Add Row to add a new pair of key value. The key will be DB driver, and the value will be Postgres. Next, a new row for the server address. Its value will be the same as in development, localhost port 8080. Note that this is just the internal address of the container. Later, when we actually deploy the app to Kubernetes, we will learn how to set up a load balancer and domain name that will route the API request to the correct container's internal address. Okay, now let's add one more row for the access token duration. Its value will be 15 minutes. And finally, the last row for the token symmetric key. Its value should be a 32-character string. There are many ways to generate a random string of 32 characters. Today I'm going to show you how to do it using OpenSSL command. It's pretty simple. We just run OpenSSL rand. Use a hex flag to tell it to output a string of only a hexadecimal digit. And finally, the number of bytes. Let's say 64 bytes to make a very long string. Actually, this string has 128 characters because each hex digit only takes 4 bits or half a byte. In our case, we only need 32 characters, so here we use a pipe to change its output to the next command, head-c 32, which means just take the first 32 characters. And voila, now we have a random string for the token symmetric key. Let's copy and paste it to the secret manager. Okay, now we have added all necessary variables to the secret. There's an option to select a custom AWS KMS key to encrypt the data, but it's not mandatory. We can just go with the default encryption key for now. In the next step, we have to give our secret a name so that we can easily refer to it later. Let's call it SimpleBank. You can also write some short description to help remind you about what values this secret stores. Optionally, we can add some tags to make it easier to manage, search, or filter AWS resources, and an option to set permissions to access the secret. But we can skip all of them for now. So let's click Next. In this step, we are able to enable automatic rotation for secret values. Simply put, we can set a schedule and a Lambda function. Then the secret manager will automatically run that function to change the secret values when the time comes. You can use it to frequently update your DB password or token symmetric key if you want. To keep this lecture simple, I'm just gonna disable automatic rotation. In the last step, we can review all the settings of the secret. AWS also gives us some sample code for several languages. In case you want to fetch the secret value directly from your code, for example, you can use this template and download the appropriate SDK to do so. We don't need to do that in our case, so let's click Store to set the secret. And voila, the secret is successfully created. In this page, we can click this button to show all the content stored in the secret. Now the secret is ready. We will learn how to update the GitHub deploy workflow to retrieve the secret values and save them to the app.env file. To develop this feature, I think we will need to install the AWS CLI. It is a very powerful tool to help us easily interact with the AWS services via the API call from the terminal. You can choose a suitable package depending on your OS. I'm on Mac OS, so I will click on this link to download the installer package. Then open it to start the installation and follow the instructions on the UI. Okay, now the AWS CLI package is successfully installed. We can run these two commands to verify that it's working properly. Which AWS and AWS version. All looking good. Next, we have to set up the credentials to access our AWS account. To do that, just run AWS configure. We will be asked for the access key ID and secret. So let's go back to the AWS console and open IAM service. Here we can see the GitHub CI user that we've set up in one of the previous lecture. On the Security Credentials tab, we can see the access key ID that's being used by GitHub Action. But for security reason, we cannot see its secret access key. So we have to create a new one to use locally. Let's copy this access key ID and paste it to the terminal. Next, it will ask for the secret access key. Let's show the value and copy it. Then paste it to the terminal. It will ask for a default region name. I'm gonna put EU West 1 because it's the main region I'm currently using. And finally, the output format is the data format we want AWS to return when we use a CLI to call its API. For me, I'm gonna use JSON format. Alright, now if we look at the .aws folder, we will see two files, credentials and config. The credentials file contains the access key ID and secret that we've just entered before. The default at the top of the file is the name of the AWS profile. You can add multiple AWS profiles with different access key to this file if you want. The default profile is, of course, the one you will use by default, which means if you don't explicitly specify a profile name when running a command, then this default profile's credentials will be used. Similarly, the config file contains some default configurations. In our case, it's the default region and output format that we've entered before. Okay, now we can call the Secret Manager's API to retrieve our secret values. You can run AWS Secret Manager help to read its manual. The subcommand we're going to use is getSecretValue. So let's run the help command again with the getSecretValue to see its syntax. Basically, we will need to pass in the secret ID of the secret we want to get. It can be either an ARN or Amazon resource name or the friendly name of the secret. You can find the ARN of the secret in its AWS console page. The friendly name is the name we set when creating this secret, which is SimpleBank. Alright, now get back to the terminal and run AWS Secret Manager getSecretValue. Then secret ID SimpleBank. Oops, we've got an error. The GitHub CI user is not authorized to perform this request. That's expected because we haven't granted permissions to allow this user to get the secret value yet. In the IAM page, we can see the GitHub CI user is in the deployment group, which only has permission to access the Amazon ECR service. What we need to do now is to give this group access to the Secret Manager service as well. So in this user groups page, let's open the permissions tab. Then click add permissions. Attach policies. Search for secret in this filter box. Here it is. Let's select this secret manager read-write policy and click add permissions. Alright, now all users in this group should have access to secret manager service. Let's go back to the terminal and run the get secret value command. We still get access denied exception. I think the permission we've just added needs some time to be effective. So let's wait a bit. And let's try using the secret ARN instead of the friendly name. Okay, now the call is successful. I'm gonna try again with the friendly name SimpleBank. It's also successful this time. As you can see, the result is in JSON format. And we have several more information than just the value stored in the secret. What we need is only the value stored in this secret string field. To get only this field, we just have to add a query argument to the previous command and pass in the name of the field, secret string. And voila, now we see only the data stored in the secret. However, its value is in the form of a string, not a JSON object. We have to add one more argument, output text, to the command in order to get the output value in JSON format as you can see here. Okay, but now how can we transform this JSON object into the environment variable format to store in the app.env file? Well, there's a very nice tool called JQ that will help us with this problem. JQ is a lightweight and flexible command line JSON processor. Let's see how to install it. On Linux, JQ is already available in the official Debian and Ubuntu, so we don't need to do anything. But it's not available on macOS by default, so we have to install it. In the terminal, let's run brew install JQ. While waiting for brew to install the package, let's take a look at its manual. There are many built-in filters and operators that we can use to transform the input JSON data. The most basic one is identity, represented by just a dot. This filter just returns whatever it takes as input unchanged. Then we have the object identifier index, or a dot followed by the name of the field we want to get. For example, here we run jq.full. So with this input JSON, it will return the value of the field full, which is 42. If the field doesn't exist as in this example, it will return null. There are many other filters, commands, and syntaxes, which I think you can discover on your own if you want. Okay, back to the terminal. Looks like JQ has been installed successfully. Let's run JQ version to verify. Okay, it's version 1.6. Now let's run the command to fetch the secret values as JSON object. We will have to change the output of this command with JQ to produce the final desired output file. First, I want to convert this key value JSON object into an array, where each object will be a separate environment variable. To do that, we will use the toEntries operator of JQ. As you can see in this example, it transforms one object with two keys, A, B, into one array of two objects. Each object has a key and a value field. That's exactly what we want. So here I'm going to change the getSecretValue command with JQ toEntries. Voila, now we have 5 different objects, each store one separate environment variable. Next, we have to iterate through them and transform each object into the form of key equal value, since that's the final format we want to store in the app.env file. For this kind of transformation, we're going to use the map operator. The way it works is very similar to the map function in Python or Ruby. Basically, it iterates through the list of values, apply a transform function on each of them, and return a new list of the transformed values. So here in our command, we can change this toEntries operator with map. And let's say if we only want to get the key of the object, we will use the .key as a transform function. Then voila, we've got a new array of strings with all the keys. Similarly, we can get an array of strings with only the values by using .value as a transform function. Okay, but what we want is a string contains both key and value, separated by an equal sign. For that, we will need the string interpolation operator. Basically, it allows us to put an expression inside a string by using a backslash followed by a pair of parentheses. As in this example, the first expression will just be replaced by the input value, while the second one will be the input value plus 1. In our case, for this map function, we will first wrap it as a string. Then the first interpolation expression should be .key, followed by an equal sign, and then the second interpolation expression will be .value. Okay, now we've got an array of 5 strings. Each store one environment variable in the desired format. But in the final output, we must get rid of the array. So to do that, we will use the array object value iterator, or a dot followed by a pair of square brackets. As you can see in this example, by using this, the array will be gone, and only the objects are printed. Let's try it. I'm going to add a pipe chain here, followed by the array iterator. Now you see only the 5 strings remained. The array square bracket and the commas are gone. The last thing we need to do is to get rid of the double quote characters surrounding the string. For that, we just need to pass in the -r or raw output option to the JQ command. With this option, the result strings will be written out without quote. Let's try it. Awesome! Now the output looks exactly as we wanted it to be. All we have to do is to redirect this output to overwrite the upload.env file. Just like that. Okay, let's check the file to see how it goes. Excellent! The whole file content has been replaced with the production environment variables, exactly as we stored in our secret. The next step we must do is to plug this command to the GitHub CLI deploy workflow before building the Docker image. But first, I need to reset all the changes we've made to the upload.env and makefile. Let's run git checkout in the terminal. Okay, now all the content of the files has been reset to the original version on the master branch. I'm going to create a new branch, feature secret manager, to make new changes. In the deploy.yaml file, let's add a new step. Its name will be load secret and save to upload.env, and it will run the commands that we've prepared before to fetch the secret values from AWS, transform them, and store in the upload.env file. We don't have to install JQ because it's already available in the Ubuntu image. We don't have to set up AWS CLI credentials either because it's already been set up in the previous step of the workflow. So let's commit this change, push it to GitHub, and open this URL in the browser to create a new pull request. This is a very simple change, so there's not much to be reviewed. Let's wait a bit for the unit test workflow to finish. Okay, now it's completed. I'm going to merge this PR and delete the feature branch. Let's open the master branch of this repo. The workflows are running. Let's check the details of the deploy workflow to see how it goes. Okay, looks like the load secret step was already successful, and the image is being built and pushed to ECR. Alright, now everything finishes without any errors. Let's open the AWS console ECR service. In the SimpleBank repository, we see a new image that has just been pushed, so it works. But I want to make sure that the image we built can actually talk to the production DB when we run it. So I will try to download this image to my local machine and run it. Let's copy this image URL and run docker pull this URL in the terminal. We've got an error because Docker cannot pull image from this private repository. We have to log in to the AWS ECR registry first in order to pull or push image. To do that, let's search for AWS ECR get login password. We're using AWS CLI version 2, so let's open this page. This command will allow us to call the AWS API to retrieve an authentication token that Docker can use to log into our private registry. So let's copy this AWS ECR get login password command and run it in the terminal. Voila, the authentication token is successfully returned. Now we will pipe this token to the Docker login command. Pass in the username AWS and password from standard in argument. Finally, the URL of our private Docker registry. We must remove the name of the SimpleBank repository from the URL. Alright, login succeeded. Now we can pull the production simple bank image to local. It's done. Let's check the images. Here it is. Now I'm going to run this image to see if it's going to work well or not. Oops, it failed at the run DB migration step. Error, URL cannot be empty. If we look at the stats.sh file, we can see that in the DB migration step, we're using the DB source environment variable. But this variable is only defined in the app.env file that our app will read when it starts. It was not set as a real environment variable of the container before the DB migration step is run. So that's why migrate complains that the URL is empty. To fix this, we have to load the variables from the app.env file into the container's environment variable before running DB migrate. If I echo DB source now, it's still empty. To load the variables to the current shell's environment, I will use the source command. So source app.env. Now if I echo DB source again, it's not empty anymore. Okay, so let's copy this source command and paste it to the stats.sh file right before the DB migrate command. Note that inside the image, the app.env file is stored in the working directory /app. So here we have to change the path to /app/app.env. And that's it. I think this will fix the issue. Let's check out the master branch, pull latest change from GitHub, and create a new feature branch for the fix. I'm going to call it feature loadenv. Add the stats.sh file that we've just updated. Commit it with the message load environment variable before running DB migration. Then push it to GitHub. Open this link in the browser to create a new pull request. Wait a bit for the unit test to complete. Then merge the pull request to master and delete the feature branch. Now we have to wait for the deploy workflow to finish. While waiting, I'm going to check our master branch on local. Pull the latest change we've just merged from GitHub. Okay, now let's see if the workflow has completed or not. It's still running. Okay, it's completed. In the AWS console, we can see the new image. I'm going to copy its URL, then run docker pull to pull this image to local. Alright, now let's run it with the port mapping 8080 to 8080 so that we can send an API request to make sure it's working well. This time, the DB migration was successful, and the server has started listening and serving requests on port 8080. I'm going to open Postman and send the first API request to create a new user. It's successful. The user has been created. Let's connect to the production DB on AWS using Table Plus and check the data of the user's table. Here we go. The user Alice has been inserted as the first record in this table. So now we can say that our production Docker image is good and ready to be deployed. And with that, I conclude today's lecture about storing and retrieving production configurations using AWS Secret Manager. I hope it was interesting and useful for you. In the next lecture, we will learn how to deploy the production image that we prepared today to a Kubernetes cluster. Until then, happy learning, and I'll catch you guys later.